Good day to all. Today we can discuss about the levels of data pre-processing in the subject foundations of data science. So why this data pre-processing needs levels? So we are collecting as raw data from surveys, sensors, transactional systems or web sources is almost never ready for direct analysis. It typically contains errors, inconsistencies, gaps and structural problems that can silently distort your results, statistical results, and machine learning models if left unaddressed. So, this data pre processing is a set of techniques used to detect and correct these problems before any meaningful analysis begins. So we are categorizing as three levels, a structured three-level framework for transforming raw messy data into clean analysis ready data sets. First level is clean up the table. Second level is unpack and restructure. Third level is evaluate and correct. So this clean up the table fits the most obvious mechanical problems in the data sets. And the level two reshape the data so that it is structurally suited to analysis, and the level 3 use domain knowledge to validate and refine the values themselves. So this staged approach will be minimizing some of the errors, and you can work without any waste and produces a more reliable analysis ready data sets. So first is level 1. So this level 1, what it indicates is clean up the table. So what it going to do in shortly, it is going to fix the most glaring surface level issues like missing data, duplicate records, then inconsistencies formats. So what is clean up the table? It is going to identify and rectify surface level issues. So most glaring straightforward problems found in the data set can be cleared out. So first one is missing data. What is missing data? Missing values are one of the most common problems in real world data sets. They can arise from non-response in surveys, sensor failures, system errors, or simply because certain fields were not applicable at the time of data entry. So in this, actually, there is two stages. One is imputation, another one is elimination. So this imputation replacing missing values with estimated values such as the mean, median or a value inferred from similar records. And elimination, what it do is removing rows or columns that have a very high proportion of missing data where imputation would be unreliable. So the real world example in a hospital patient data set, a blood pressure column might be missing for 2% of records due to faulty sensor. So we can take this average, that is by using the mean blood pressure for similar patients, preserve the data sets while limiting distortion to the analysis. Second type is duplicate records. So what did this duplicate records do? Duplicate records occurs when the same real world entity or event is represented more than once in the data set. So it did what we are going to do is in this level, data professionals identify and remove the duplicate entries from the data set to ensure data integrity. So that is the overall aim for to remove the duplicate records. This often involves comparing key fields such as customer ID and timestamp to detect records that refer to the same underlying event. And the third one is inconsistency formats. What is this inconsistency formats represents? Data collected from various sources may exhibit inconsistent formatting. So making it a challenge. Some will be having as a date in the format of 6 May 2026. Some will be representing as 5/6 2026. So the data will be in inconsistent format. So some of you will be using abbreviations instead of giving a full thing, as well as if you're going for some addresses, a shortcut will be used for street st, like that some valid varied sources will be there. We are going to use it will by enabling the meaningful analysis. So cleaning up the table involves standardizing formats for dates, addresses and other data elements so that can be processed and compared consistently. Next is outliers. So what is this outliers represents? Outliers are extreme values can simply significantly impact the statistical analysis. A single unusually large or small value can skew the averages, distort correlation or mislead a predictive model. So level 1 uses basic outer detection techniques to identify and potentially correct or remove them. And the fifth one is data type mismatches. What is this data type mismatches represents? So ensure data types are consistent. So converting test data into numerical format whenever necessary. Like in the price columns, it will be stored as 39.99. So some will be round off and it will be giving us 40. So that is nothing but the data type mismatches. So these are the four important tasks done by the level 1 missing data, duplicate records, inconsistent formats, outliers, and data type mismatches. So what is this level 2? What is this level 2? Unpack, restructure, and reformulate. So it is going to reshape the table to be in analysis ready, future engineering, transformation, and aggregation. These are the three things which you are going to see in your third one. So what is this? Unpack, restructure, and reformulate. So, after level 1 addresses fundamental issues, level 2 reshapes the table. So, reshapes the table means it is going to reshape the table structure and content so that it better support the analysis that follows. So, first is feature engineering. So, what is feature engineering involves? It involves creating new features or variables based on existing data to capture important information that is not directly present as a column. So, feature engineering can enhance the data set's predictive power and make it more informative for downstream modeling. So, from a single date of birth column, a customer age feature can be engineered. So, that is one example we can quote. Next is data transformation. So, what is the data transformation? It involves transforming data using techniques like scaling, normalization, log transformation to ensure that variables have suitable distributions for analysis. So, many statistical and machine learning techniques is going to use this data transformation. Next is aggregation. What is this aggregation stands for? It is going to do two things. One is token that include level 2 may involve test data processing, aggregation. For example, summarizing daily sales data into monthly totals to facilitate higher level analysis. Then aggregation is especially useful when the question being asked operates at quasi level of granularity than the raw data was collected. So instead of using the daily data analysis, we can go for monthly analysis, then yearly analysis. Like that, you are going to add your data levels. Next is test data pre-processing. When the data sets include test data, the data is in the form of test. We are going to do three things: tokenization, stemming, or sentiment analysis to extract your meaningful sites. So, for example, we can have the techniques convert unstructured tests like customer reviews or support tickets into structured form that can be analyzed quantitatively. That we can have as an example. So, tokenization means splitting test into separate words or meaningful units. And stemming means reducing words to their root form. Example, running to run. Example, we can say. Sentiment analysis means determining whether a piece of text expresses a positive, negative, or neutral sentiment. And the fifth one in your second level is combining tables. So this combining tables means integrating the data from multiple sources or tables to create a more comprehensive data set for analysis. So it is done by joining or merging on common keys such as customer ID that appears in both an orders table and a customer profile. So we are going to combine it as a single data set. So in the level 2, we have feature engineering, data transformation, aggregation, test data pre-processing, and combining tables. Next is level 3. So what this level 3 is going to do? So the level 3, evaluate and correct the values. So we are going to apply domain knowledge to validate and correct the data values themselves in depth. Also, it is going to, this level is more advanced and requires deeper understanding on the data and so because we are going to apply some domain knowledge, so it will be having a high technical knowledge. So what is this level 3 does? So it is going to deep domain aware value correction, we can say. In the final and most advanced level, we are going to use this. So first one is domain validation. So what is that domain validation? It involves verifying the validity of data values within the context of the problem domain. So example, ensuring age value falls within a reasonable range, 0 to 120, or that product prices are positive. So a value that can be perfectly well formatted still be wrong, and domain validation catches errors and purely it will be going to change the data. So, for example, if the date age is mentioned as 1000, it is wrong. So, it is going to validate that because we are going to identify, we know that the data will be having the age value between this range. So, we are going to validate that. Data imputation. So, addressing the stage deals with the missing data that could not be addressed in level 1, which causes where a simple statistical estimate is not enough. So we are going for advanced imputation techniques such as machine learning based imputation to estimate your missing values. Third one is outlier detection and treatment, applying more advanced statistical and machine learning techniques and then decide to construct it. So for example, a transaction of 50 crores might initially look like an outlier. Domain knowledge, knowing the account belongs to a business that regularly makes large transfers, we are going to allow it. So that is actually the case. We are going to use in the outlier detection and treatment. Example, we can say. Fourth one is data quality assessment. So it is going to conducting comprehensive data quality assessments by using statistical tests and data profiling to identify subtle issues that were not appropriate in earlier levels. So this step involves or provides a systematic measurable view of how trustworthy the data set is before it is used for analysis or modeling. Next is data validation rules. Implementing validation rules and checks ensures data accuracy and consistency going forward. These rules may include referential integrity checks, data range validations, and logical consistency checks. So what is referential integrity checks? So it ensures that references between tables, example, a foreign key point to valid existing records. Data range validation confirming that values fall within an acceptable and predefined range. And logical consistency checks means verifying that related fields are consistent with one another. Example, a ship day should not be earlier than the corresponding or order date. Example, we can say. So all those things coming under this data validation role, that is in level 3, sorry, there are 5 things: domain validation, then data imputation, outlier detection and treatment, data quality assessment, and data validation role. So these are the 3 important levels in data pre-processing. Clean up the table, unpack, restructure, and reformulate, then evaluate and correct the values. Hope you have understood this. Thank you.